In this lecture, we'll go over a brief history on computers.
I like how that turned out. We'll now take a look at the historical development of the computer systems. Now, unlike other inventions where they were created and then maybe some slight improvements were made on them, the computer wasn't created in a single event. It wasn't just like, okay, we invented a computer in one day and then that's the end of it. No, the thing about the computer is it actually evolved over hundreds of years. Now, most of the advancements have been made in the past 50 to 60 years, but the computers that we have to this day have been based on several advancements, several improvements over the past several hundred years. We'll start by looking at what we consider the early period of computers, which is everything up to 1940. We'll start by taking a look at advancements in mathematics. And this is because computer science is basically applied math, where we are performing computations, we're doing calculations in a very efficient manner. So that's why we're going to start by looking at some math. So this all started 3,000 years ago with the early work of the Greeks, Egyptians, Babylonians, Indians, Chinese, and Persians. So all these different cultures were interested in and made important contributions to the fields of math, logic, and numerical computation. So let's take a look at some examples. So for instance, the Greeks developed fields of geometry and logic. Babylonians and Egyptians developed numerical methods for things such as developing square roots, multiplication tables, trigonometric tables, and these were used by early sailors just as a one application. Indian mathematicians also developed the base 10 decimal system that we use today, and they also developed the concept of the zero, of what it means for something to be zero. And then in the 9th century, Persians developed the algorithmic problem-solving approach that we use to this day. We'll now fast forward to the 17th century, where we've seen even further advancements in mathematics. In 1614, John Napier invented logarithms, and these were used to simplify difficult math computations. In 1622, the first slide rule was invented, and then in 1672, a guy by the name of Blaise Pascal designed and built one of the first mechanical calculators. And this calculator could add and subtract. It couldn't do anything else, but you can remember, this is one of the first mechanical calculators, so it was a pretty big advancement. In 1674, a guy by the name of Gottfried Leibniz constructed the Leibniz wheel, and this could add, subtract, multiply, and divide. So it was a more advanced calculator, and sure enough, nowadays we would see this as just very basic computations, but these were mechanical stuff. So these calculations use rotating gears for storing numbers. So each wheel would represent a digit. So you would just rotate a wheel and use that for storing numbers and do your calculations. Now, the key thing here is that these are not computers, because while we are keeping track of numbers, they don't have any memory, and we couldn't write any programs. We couldn't have anything automated. We still had to manually turn these wheels in order to do the calculations. We now get to the first computing device, and believe it or not, it was not originally used for mathematical computations. Instead, it was originally used for manufacturing rugs and clothing. So in 1801, we have this Frenchman by the name of Joseph Jacquard who created this device. And the idea was that he wanted to automate the weaving process of creating rugs and clothing, because back then it was painfully long and tedious, because in each separate row of the pattern, it had to be set up by the weaver and an apprentice. So they were limited to just the most basic styles of clothing for doing all the weaving. So what Jacquard did is he used punch cards to create the desired patterns. So the idea with this is for each hole in a punch card, a hook would pass through the hole, and each card was one row of the pattern that we needed to make. So then the cards were connected one card at a time and fed through this loom. So the first card would take care of the first row, the next one would take care of the second row, and so forth. So when you get through all the cards, you had your complete design. and it definitely helped simplify the process. So these punch cards, the idea was actually used much later on, and we'll get to that later on, but in like the 60s and early 70s, we see punch cards being used as input to our computers. We see the next advancement in 1823 from a guy by the name of Charles Babbage. And he created what was called the difference engine. And this was a huge advancement. So this device could add, subtract, multiply, divide, and even solve polynomial equations. So I mean, this was huge back then. Now, it only went up to 6 significant digits. He tried to build a larger version that would go up to 20 significant digits, but he was not able to do so. The technology back then just simply was not available to handle all the cogs and the gears that were needed to get the right accuracy. Now, eventually, this was built by the London Museum of Science in 1991, and it used the actual working model of the difference engine. Now, this thing was about 7 feet high, 11 feet wide, it weighed about 3 tons, and it had about 4,000 moving parts. But it did work exactly as Babbage had planned. Now, just because Babbage wasn't able to build the exact difference engine that he had hoped, didn't stop him from continuing with his work. In fact, in the 1830s, he built a more powerful and general purpose computational machine, which was called the analytic engine. And this could be configured to solve a much wider range of numerical problems. And the parts that were used in this engine were very similar to that of a computer. So it had a mill, which performed arithmetic manipulations of data. So this is similar to the arithmetic unit that's in a computer. It had a store, which held all the data. So this is just like our memory in a computer. It had an operator that processed instructions that were contained in the punch cards. Remember, when we were talking about the punch cards before, I mean, this was the first time that we had an actual program. So here we have an operator, which is similar to our modern day processor that read each instruction and did whatever was said on the punch card. And then we had an output unit, which is similar to our input output that are used in today's computers. And the output unit placed the results onto separate punch cards. Now, Babbage passed away before a working version of the analytic engine could be completed, but his ideas did live on and inspire other people. One such person is by the name of Herman Hollerith, who worked with the U.S. Census Bureau. And in the 1890s, he designed and built programmable card processing machines. And what they did is they could automatically read, tally, and sort data that was entered onto punch cards. In fact, these were used for collecting census data. This was a huge success. It just completely sped up the process of processing all the census data. So prior to this, in the 1880s, it took many years to complete the census data. In fact, the 1880 census took 8 years to complete. The 1890 census took 2 years to complete. And I mean, that was a huge improvement. I mean, still 2 years to complete census data is quite a bit of time, but it was much faster by using this approach. Now, in 1902, he did leave the Census Bureau and founded his own company. So this was called the Computer Tabulating Recording Company, and he built and sold these machines that would process census data. Now, in 1924, he renamed it to a company that you're probably familiar with, which is called IBM.